We often talk about the universe as if it's something we can eventually map, explore, and understand in its entirety. But there's a hard boundary that even our most powerful telescopes cannot cross, a cosmic horizon that marks the edge of what we can observe. This boundary raises one of the most profound questions in modern cosmology. What lies beyond the observable universe? The observable universe is not the entire universe. It's simply the part we can see. Light has a finite speed, and the universe has a finite age, around 13.8 billion years. This means there's a limit to how far light can have traveled since the Big Bang. That distance forms a cosmic horizon, currently extending about 46.5 billion light-years in all directions. It may seem counterintuitive that the observable universe is larger than 13.8 billion light-years. That's because space itself has been expanding during the travel time of light. Distant galaxies are not just far away. They're also receding from us as the fabric of space stretches between us. So, what's beyond that horizon? The truth is, we don't know, and may never know. According to our best models, the universe could extend infinitely beyond what we can observe. That means the 93 billion light-year wide bubble we live in could be a tiny fragment of a much vaster cosmos, a speck of dust on an infinite tapestry. If the universe is flat, as current observations strongly suggest, then infinite extension is a real possibility. In such a universe, every galaxy we see could be just one of countless others, stretching endlessly beyond our detection range. But there's more. Beyond the edge of visibility, we may find regions with different histories. Inflation theory suggests that the early universe underwent a brief period of exponential expansion. This process could have created vast cosmic patches, each inflated from quantum fluctuations, each potentially with its own properties. Some of these patches may be similar to ours. Others could be radically different, with different particles, forces, or even dimensions. This is the basis of the inflationary multiverse, where what lies beyond the observable universe is not just more of the same, but perhaps something entirely new. In this framework, the universe is not a single uniform space, but a cosmic mosaic, a collection of bubble universes birthed from the same primordial field. But here's the catch. We will likely never observe these other regions directly. The light from them hasn't had enough time to reach us, and may never reach us, especially if the universe's expansion continues to accelerate due to dark energy. This brings us to a mind-bending realization. There are parts of our own universe we will never see, not because they don't exist, but because the space between us is expanding faster than light can bridge it. In time, even more galaxies will slip beyond this cosmic event horizon. Eventually, only the closest structures, like our local group of galaxies, will remain visible. This isn't just a limit of technology. It's a limit of physics. Imagine standing on a shore, watching ships disappear over the horizon. The ocean goes on, but you'll never see what lies beyond that curve. In cosmology, the edge of the observable universe is our cosmic shore, and we are stranded on it. And yet, we still search. Scientists analyze the cosmic microwave background, CMB, the oldest light in the universe, looking for anomalies that might hint at collisions with other bubbles. So far, the CMB appears remarkably smooth, with only subtle variations that match predictions from inflation theory. But if other universes do exist, and if some ever brushed against ours in the early cosmos, they might leave behind a cold spot, a ripple, or a statistical oddity. Researchers continue scanning the sky for these clues, faint fingerprints from beyond. There's also the possibility of gravitational waves from beyond the horizon. Unlike light, these ripples in space-time may carry information from earlier epochs or even from neighboring universes, though detecting them would require instruments far more sensitive than any we currently possess. Still, Some theorists argue that if inflation and quantum mechanics are correct, then the existence of a larger multiverse is not just possible, it's inevitable. And if the universe is infinite, then so are the possibilities. Somewhere, far beyond what we can ever see, there may be another Earth, another you, reading this sentence, or a reality where the laws of physics differ entirely, and life takes a form we cannot imagine. All of this from a place we can never visit, hidden not behind a wall, but behind time itself. This boundary between what is known and what is unknowable is one of science's most poetic frontiers. It reminds us that no matter how far we reach, there will always be mystery. Always something more. Always a question just out of reach. And maybe that's the point. The edge of the observable universe is not a failure of knowledge. It's a celebration of it. It's the place where our understanding meets imagination. A reminder that we are explorers not only of space, but of ideas. Beyond the edge lies not darkness, but wonder.